B tree is a generalized form of binary search tree, and it is also known as the height balanced MV search tree. So coming to the definition of B tree, or what is B tree? B tree is a special type of self-balancing search tree in which each node can contain more than one key and can have more than two children. That is, if there are n children, there can be n minus 1 keys. Note that the number of keys in a node and the number of children for a node depends on the order of the B tree. Okay, so every B tree has an order, and the B trees are designed to work well on the disk or other direct access secondary devices, and they are better at minimizing the disk IO operations. Okay, so why we are using the B tree? So as we have said, the B tree is mainly used for disk access. So the need for B tree arose with the rise in the need for accessing the physical storage media like the hard disk in lesser time. Okay, so even though the secondary storage devices have larger capacity, they are slower in processing. So there was a need for such a data type that minimizes the disk access. So the other data structures like binary search tree, AVL trees, red black tree, etc. can store only one key in a one node. So if you have to store a large number of keys, then the height of the such trees becomes very large and the access time increases. So when we are coming to the B tree can store many keys in single node and can have multiple child nodes. So this decreases the height significantly, allowing faster disk access. So this is the main advantage or main reason of using the B tree, because of its capability to store large number of keys in a single node and large key values by keeping the height of the tree relatively small. Okay, so now coming to the B tree properties. First property, all the leaf nodes must be in the same level. The second property, if m is the order of the tree, each internal node are the non-leaf node, so each internal node can contain at most m minus 1 keys and can have m number of children. So if there are m number of children, there will be m minus 1 keys. Okay, so coming to the third property, each node except the root node can have at most m children and at least m by 2 children. Okay, fourth property, the root has at least 2 children and contains a minimum of 1 key. So coming to the fifth property, all the nodes except the root node must have at least m by 2 minus 1 keys and can have maximum of m minus 1 keys. And the last property, all the key values in a node must be in ascending order. We will make it clear by using an example. So this is a B tree of order 5. So here the maximum keys can be m minus 1. So 5 minus 1, 4 keys. So maximum of 4 keys and minimum of 2 keys. Maximum children m, so 5 children. Minimum children can be m by 2. So here the order is 5. So 5 by 2 is 2.5. We will be taking the ceiling. So it will be 3. So if we have 3 children, we should have minimum 2 keys. So here these are the keys and these are the children. Okay, so it satisfies all the properties of B tree. Now while performing some operations on B tree, if any property may get violated. So in that case, we maintain the properties by borrowing from the immediate left or right node or by joining the two nodes.